how we find oxidation. Okay, so what we're going to do as our examples, we're going to find the oxidation number of sulfur in a few different examples. So we'll start off with the compound H2S hydrogen sulfide, and we're going to find this oxidation number. So we're going to use number 6, which says, rule number 6, which says the sum of oxidation numbers is 0 in a neutral compound. This is a neutral compound, so what we're going to do is we're going to set it equal to 0. Now, we're trying to figure out sulfur, so we're trying to figure out sulfur. That's going to be our variable that we try to figure out. And sometimes I just use X there, but I'll use S right now because it stands for sulfur. It's fun. Okay, so then we're going to look at hydrogen first. So we're going to say we have 2 hydrogens, and we're going to multiply those 2 hydrogens by hydrogen's oxidation number. Now, hydrogen normally will form an oxidation number of a +1. So we're going to multiply 2 times +1. And then we're going to solve this for S. So we have +2 plus S equals 0. So obviously you can see that S is going to be solved, and it's going to be equal to -2. And that's the correct answer. We would say sulfur has a -2 oxidation number here. Let's look at another example here. So let's look at another example, SCl2. This is a molecular compound. Again, this is going to be a compound that is neutral, so we're going to set it equal to 0. Again, we're looking for the sulfur. And because we have 2 chlorines, we're going to multiply 2 multiplied by chloride would normally form a 1- charge. So we're going to do a -1 here. And so now we're going to have sulfur plus -2 equals 0. And obviously in this case, when we solve this for S, sulfur is going to equal to +2 in this case. Let's look at another one here. We'll take a look at the sulfate ion, SO4 2-. Now, because we have a charge of a 2- here, we're going to set this equal to -2. It's going to be sulfur plus, we have 4 oxygens, 4 times, each oxygen is going to have a charge of a -2, -2 just like that. So now we have sulfur plus -8 equals -2, and we're going to solve this for sulfur, moving that 8 over, and so sulfur is going to be equal to +6 in that one. And then the last one we'll do, let's do one more, in Na2SO3, and this guy is going to be a neutral, and so let's set this equal to 0, and for our Na we'll start out with, we have 2 sodiums, so we're going to have 2 multiplied by sodium forms a -1 charge. I'm sorry, it's a +1 charge. Made a mistake there. We're going to add that into the sulfur. We're going to add that into our oxygen, which we have 3 oxygens here multiplied by a -2. And so then we're going to have +2 plus sulfur plus -6 equals to 0. And so we're just going to basically solve this guy. And sorry about that. So now we are going to have equals 4. And there we go. Okay, so let's take a look at another problem, and we're going to incorporate in this idea of oxidation numbers and to determine who is oxidized and who is reduced. And so we have solid manganese, which is Mn, reacting with lead-2 nitrate solution. And this one takes the same form of a single replacement reaction, so the manganese is coming in here and it's going to replace the lead. Manganese can form multiple charges. We're just going to say in this case manganese is going to form a 2+ charge again. And then lead gets knocked out just like this. Now, if this is a solution of the lead-2 nitrate, what we're going to do is go ahead and ionize this guy out. So we're going to have our manganese solid, don't ionize that, Pb2 plus NO3 1-. Over here we have a nitrate, so we are going to ionize again. And just like that, we do not ionize the Pb, that's a solid being formed. Usually when you knock a single metal out of a compound, it just forms a solid, sinks to the bottom. nitrates are going to cancel here, and then so we have our net ionic equation of Mn solid plus Pb2 plus yields Mn2 plus Pb solid. Now, what we're going to do is go through and put oxidation numbers on each one of these, and so if we can see if we can figure out how to figure out who is being oxidized and who's being reduced. So the manganese is solid. Anybody who's a solid over here is in its elemental form, so that's going to be a 0, and over here on the Pb, solid as well, and that's going to be a 0 there. The 2 plus on the Pb is going to be a +2 for oxidation, and onto the manganese, it's going to be a +2 as well. So what we're doing here is we're going to be looking at the manganese here and the manganese here, and what's happening to the manganese for it to go from a 0 to a 2 plus. Now, when it goes from a 0 to a 2 plus, what that tells us is that there is actually a loss of electrons occurring, and loss of electrons is going to be oxidation, using our Leo says GER, or the other way around. Over here on the lead, we have Pb. I'm going to rewrite it down here, just a half reaction, Pb solid, and we have a +2 charge going to a 0 charge. And the way I remember it is we're reducing the oxidation number. We're going from a positive charge down to 0, so we're reducing that charge, and so this is going to be reduction, which is gain of electrons. And that's how we use this. So, because sometimes it's not so easy just to look at atoms or molecules and just see who is being oxidized and who is being reduced. So we have to use the oxidation numbers, and we'll do more practice on this tomorrow in class. And that's the end of today's lecture.